Hey, what's going on, guys? It's Mr. Sanchez here coming with a lesson for pre-calculus. We're doing section 2.1. Functions this is the first half of this section. It's kind of a long section, so I decided to break it up into two parts. Um, that way we have enough time to cover everything. Section 2, like I said, revolves around functions. Our learning targets for today are to determine whether a relation represents a function and to find the value of a function given a point, right? But first things first, let's review some of our vocabulary that we're going to be using. Yeah, okay, so first things first, we're going to go over what a function is. A function is a relation in which each input has exactly one output, and that's the most important part. Each input can only have one output. All the inputs in a function are called our domain. Domain, our input is our inputs, and range is the set of all outputs for a function. So any output that a function gives you, that's considered the range. And this is all reviewed from algebra 1/2. It's covered in both classes, right? And in this class and in calculus, and it basically stays the same. Uh, we're going to be shown some relations. Relations just a mapping from one thing to another. We're going to state the domain and range, then determine if there's a function. And we're going to first start off with a mapping. If you don't know what a mapping is, it's going to look like the following situation. You're going to have one thing, you're going to have two things. One is going to go to the other. That's what we call a mapping, right? We give something from one set gets you to the set of another. It has an output of another. So right here we have the price per gallon at gas stations. And yeah, so price per gallon at a gas stations. All right, so one thing you'll notice is Chevron. If you go to Chevron, you're gonna pay $2.09. You go to Shell, you're gonna pay $2.16. And if you go to Gulf, which I've never heard of, you're gonna pay $2.21. And apparently, if you go to Exxon, you're gonna pay 216 cents. I got this problem straight from your book, so as you can tell, these are very generous gas prices. Since here in California, we're out here paying $4 or $5 per gallon. So not accurate, but you know. Anyways, first things first, we're just gonna state the domain and range. All right. The domain is the part that is going towards our range. So our domain usually has an arrow going to our range, right? So our domain here is gonna be our gas stations. Okay. Our domain is gonna be the gas station, right? Because depending on which gas station you go, we're gonna find out how much you're paying for gas, the price per gallon, right? So that means that because this is the domain, that must mean that this here is our range. Okay, so our range is a price per gallon. And that's not so hard, right? All right. The next thing it asks us is it a function, yes or no? So we look at our definition of a function, it specifically states it's a relation in which each input has exactly one output. All right, so let's go over here and let's just start with each. All right, so we looked at Chevron and it maps to one output. So far, so good. You look at Shell and that has one output. Okay. You look at Gulf and that has one output, so we're good. And we have Exxon, and Exxon also has one output. You'll notice it goes to the same output as Shell. That does not matter because all we care about is that each input has exactly one output. And so because it turns out to be true, then yes, this is a function, okay? Go ahead, write this down on your notebook. You should be writing all of this down in your notebook. I just write this before we start the lesson, so it takes time in the video, run time. All right, let's go on to our next example, okay? Next example says diamond prices, right? It's the same thing. We're gonna determine our domain, our range, and whether it's a function or not. Now, like I said, our domain usually is something that maps something onto our range, right? So right here, we're looking at the prices of diamonds, and our carats are how many carats we have of diamonds is gonna depend on our price in gold, right? our price, right? So you look here, you have 0.7 carats. That's gonna give you $15.29, but not even $15, 1,529. You have 20. If you have 70.71 carats, you're either gonna pay 1575 or 1952. And yeah, 75 is 0.75 is going to make you pay 1765, and 0.78 is going to pay 1798. So real quick, since the left is being mapped onto the right, this is going to be our domain, and this is going to be our range. Now, normally you want to list the values, right? So our domain here is going to be 0.70, 0.71, 0.75, and 0.78. All right, that's our domain. And our range is going to be the prices, right? 1529, 1575, 1765, 1798, and 1952. So one thing that I want you guys to notice is that if you look at the input 0.71, that has two outputs. Now, by definition, our input can only have one output for a function. So this is not a function, okay? Because 0.71 has two outputs. And so the moment you have one output, boom, done. One output for one input, that is. Okay? Go ahead, write that down. And so that's what we call mappings. There's another way to determine functions, whether or not functions are functions, and we got to look at what we call or set of ordered pairs. So right here, you'll see we have our first set, okay? And it's the same thing. We're going to state the domain, we're going to determine the range, and determine if it's a function, okay? So first things first, it's a set of ordered pairs, you know, so these are points, right? So whenever we get ordered pairs, the first number is X, second number is Y, X, Y, X, Y, X, Y, okay? Our X values are always gonna be the domain. 1, 2, 3, 4. Oops, 3, 4. So that's our domain, right? And we're gonna write that in this squiggly bracket. 1, 2, 3, 4, right? You write squiggly bracket because that lets people know we're talking about a set, okay? And our range is always the second number, the Y values, right? That's our output. So 4, 5, 6, 7. And you notice no input gives you two different outputs. So this is in fact a function. Yes, it is. Next up, we're going to look at another set of ordered pairs, right? And that now we have this new one. All right, so once again, it's X, Y, X, Y. All our X's are our inputs, right? And so let's go ahead and write that our domain. So we're going to have -3, -2, 0. And then we repeat -3 here. So we don't need to write that down because that's included here. So we're going to go ahead and close it. All right. Now let's look for our range. That's our outputs, 9, 4, 0, 8. So let's write that down. 9, 4, 0, 8. And you can write this in numerical order. It doesn't really matter so long as you include all the numbers in there. Okay. Now, one thing I want you guys to notice is we have -3, 9 and -3, 8. So this is the same X giving you two different outputs right here. This X is giving you a 9 for Y, and -3 is giving you a +8 for Y. That automatically tells us that our input is having two outputs, and therefore that tells us that it is not a function. Okay. And yeah, that's pretty much it. This is how we determine whether or not a function is a set or not. Okay. Let's go ahead and move on. And then there's one more example, and then we're done for this half of the lesson. All right. Example 5 says determine whether or not x squared plus y squared equals 1. Defines y as a function of x. Okay, so what we got to do here, you notice that they give us this equation here. This is called our implicit form, okay? It's an implicit because y is not by itself. So we're gonna go ahead and get y by itself. Let me rewrite this equation. We have x squared plus y squared equals to 1. We're gonna get rid of x squared from both sides, and you're going to get y squared is equal to negative x squared plus 1. We're going to square root both sides, and you're going to notice that we're going to get y is equal to plus or minus the square root of negative x squared plus 1. Okay, so this is called our explicit form, okay? It's explicit because we know what y is. Now all we gotta do is let x be a number to test it out. Oh, we have another one. I'm sorry. We're going to let let's say let x equals 1. Let's see what happens when we plug in 1. So we're gonna let y is equal to plus or minus negative 1 squared. No, that's not a good number. I'm sorry. We're not gonna let it equal to 1. This is a bad one. I'm sorry. I chose a bad number. We're gonna let x equals to 2. All right. Negative 2 squared plus 1. Okay. This is going to give us plus or minus negative 4 plus 1, which is plus or minus square root of negative 3. All right. One thing you'll notice is that we have an imaginary number, so this is not a good number either. I'm sorry, guys. We're gonna choose an even easier number. All right, and we're going to let x equals 0. Okay, this is the example I wanted to show you guys. Okay, so that means we get 0. 0 plus 1 is 1, which gives us the square root of 1 is plus or minus 1. All right, so we have one input. What do we let our input be? X is equal to 0, and that's going to give us 0, 1 and 0, negative 1. You see, because we have this plus or minus part here, that means that this function is this equation is not a function, and it's actually the equation of a circle. So it kind of makes sense why it's not a function. Okay, and that's how we can tell. All right, it gets a little tricky. Like I said, I got a little confused right there. But the moment you see plus or minus on the outside, that's kind of the indicator that, oh, okay, our equation's not gonna have a whole number. I mean, it's gonna have more than one output, okay, for the same input. Okay, now this is the last example. Okay, I'm sorry. Now we have to find values of a function. All right, so we're switching gears a little bit, and all we gotta do is plug some stuff in. Okay, so f of 3. We should just review. F of 3 means you're gonna plug in 3 wherever x is. Okay, so you're gonna write 2 times 3 squared minus 3 times 3. Right? 2 times 3 squared is 9. So it's 2 times 9 minus 9, which is equal to 18 minus 9, which is going to give us 9. Okay. You see 3 f of x? So what this means is you're going to multiply 3. That's what this means. Times f of x. What's f of x? This is f of x. So you're going to write 2x squared minus 3x. So what does that mean? That means you're going to have distribute, all right? So 2 times 3 is 6x squared, and then 3 times negative 3 is negative 9x. And that's our answer, okay? Next one up is a nearly easier one. So this is saying f of x plus f of 3. So what's f of x? F of x is 2x squared minus 3x, right? Plus f of 3. We kind of already know what f of 3 is, so we don't have to reevaluate, but if there's a number we don't know, we got to plug in f of 3. We know that's 9, so we're going to do plus 9, because that's what f of 3 is, right? And that's our answer. For the last one, it's a little bit trickier. You're going to plug in x plus 3 wherever our x is. So remember, our x is 2x squared minus 3x. So what does this mean? It literally means that wherever you see x, you're going to write x plus 3 inside. And then you're going to have to FOIL it out, okay? With some FOILing, you're going to know that this becomes 2 times x squared plus 6x plus 9 minus, and then 3x minus 3 minus 9, right? Because it's negative, this becomes negative as well. And then you continue FOILing, you're going to get 2x squared plus 12x plus 18 minus 3x minus 9. And you're going to continue evaluating this. Okay, this is the only term with x squared. So you're going to rewrite that as 2x squared. You're going to have 12x minus 3x, which is going to be positive 9x. And then 18 minus 9, which is negative 9. I mean, positive 9. And this here is going to be our equation. Okay. And that's basically it. If you have any questions, we will be practicing this in class. Don't be afraid to ask any questions in class, or message me on Schoology. Maybe leave a comment if you're watching this on YouTube. But yeah, this is the first half of section 2.1. This is still technically considered review, but this is more algebra 2 review, whereas what we were focusing earlier was algebra 1 review. Okay. Anyways, guys, have a great day. Bye-bye.